people have questions later on, that's fine too. We'll just run right into it. I'm going to cover several things today, specifically about key management standards. If you've been active in the cryptography community, if you deploy cryptographic devices, if your enterprise is in the financial sector, pretty much anybody that has used or will deploy cryptographic devices in the next couple of years is going to be concerned about key management standards. We're going to go over the problems as to why there's so many different key management products, or why so many cryptographic systems have their own key management products. The problems around interoperability. The contenders, as I like to say them, these are the 4 different standards that we'll be covering today. We're going to go through each one, basic message set of each one. One of them does not actually specify a message, but we'll go into some details on that. And we'll see where each of these plays out, so to speak, in the industry, where the overlaps are, you know, who the players are, that sort of thing. And then finally, we'll go through the actual details of each of the standards. Before we jump into it, anybody from any of the 4 committees that I'm going to talk about? OASIS, KeyMap, EKMI, IEEE 1619.3. Which one? Which one? The KeyProv? Yeah. Okay, good. And anybody else from KeyProv? Okay. So in the last several months, I've talked to members of these communities, different chair members, all these different committees, to get their kind of take on the industry as a whole, their place in the world, where they overlap with other standards, that sort of thing. I spoke at NIST, which is the American standards body, a government standards body, about a month and a half ago. And Phil Hoyer from the KeyProv committee was there, and we talked quite a bit about this stuff. And as somebody said earlier, if you don't have lolcats, then you know your presentation just isn't there. So I had to run and grab this real fast. I'm in your house stealing your keys, so that's just hopefully to break the ice a little bit here. More keys. We're going to talk about the first piece here, all the different uses of keys, key management, cryptographic devices, all that sort of fun stuff. I took this picture yesterday at the Imperial Treasury. So if you guys are tourists or if you're local Viennese, you can go down to the Imperial Treasury and see these keys. It's actually quite an interesting facility and museum. Although if you're a native Viennese, I will tell you that just standing there, I saw at least 2 or 3 different ways to break into the case and not get caught. So maybe the keys aren't that important as the crown and that sort of thing. So this is a snapshot of the problem, right? Anybody that has deployed or used or has thought about cryptographic systems in their enterprises has this problem. How many have to deal with PCI? Financials, credit card companies, so maybe sort of. How about EU privacy? Yeah, everybody, right? Yeah. EU privacy. I don't know if there's an equivalent to HIPAA here in the EU, but HIPAA is a healthcare privacy initiative in the U.S. Yeah, big time, right? So a lot of the different, and if anybody's interested in different standards or laws or legislation about cryptography, you can come see me later. That's not really where I want to go, but suffice to say that in your enterprises, cryptographic products are deployed, period. There's nobody in this room that should raise their hand and say, I don't use cryptography in my environment at all. Either you're using SSL, symmetric keys to protect data at rest, asymmetric keys to do signing, certificates, whatever the case may be. And some enterprises use this quite extensively. Give an example, financial services industry in the US, there's a body that's called the FFIEC. Don't ask me the acronym, I can never remember. But basically they say, thou shalt encrypt all your data that goes to tape, all your archive data. That's pretty common practice. It's very widespread. But the reality is that in financial systems, you have mainframes, you have mid-range systems, and you have distributed systems. Well, for each of those three major platforms, you might have a different tape system to encrypt your data, or just to write tapes in general. So each one of these different systems to write tape might also engender some different system to encrypt that data. So as you can see here, you have this plethora of devices in your environment, and each one has their own key management system. It's great, right? All these symmetric key products that are out there. You can buy something from EMC, RSA, or from IBM. I should ask first. Anybody from IBM? Okay, good. Anybody from EMC or RSA? Oh, even better. And anybody that is from Sun, Oracle? Oh, great. This is really good. So this will be good because I can dish on all the fun political stuff that goes on and these vendor love fests that happen during these standards meetings. Just full disclosure, I participate in the standards community as an individual, not as a vendor representative. So I get to, be the objective observer, right? So anyways, all these different key management systems all have their own symmetric key management systems to go along with them, right? Some of them have overlap. Some of them say, well, if you have brand X, then you can manage the keys from brand X on brand Y. IBM used to tell me this all the time. They say, no problem, you've got all these systems. That's great. Why don't you get all your keys and we'll put them on the mainframe? All right, well, that's great, but how do I get them to the mainframe? Oh, just export them out of whatever symmetric key system you've got and just drop them into the mainframe. We'll store them just perfectly. Well, that's not really key management, right? That's key storage. Or they might do key generation, or any of the vendors that are out there would say, well, I'll do these 3 pieces of the key management lifecycle, but not the other 10 pieces or whatever. The final result is that all these different systems have proprietary protocols. They're very disparate. They're not interoperable. All the different devices out there speak their own language, their own authentication systems. They're just completely different. And this is a big problem because if you're anything like my environment was a few years back, I had every single brand of HSM, every single brand of storage, every single brand of network device, and they all use their own proprietary systems to manage keys. And that was a real pain in the ass. This is just a kind of a graphical demonstration of what we've been talking about. You can see up at the top there. I hope everybody can read that. It doesn't matter what's in the boxes, but you can see that for each different type of system you have, you might also have a different type of application. Everybody's familiar with web servers and SSL certificates, right? Okay, well, these systems, you might have certificate systems that are spread across client, server, network environments. But, for example, over on the storage space, the storage side is largely dominated by symmetric key systems because symmetric keys are faster. You can encrypt, bulk data very quickly rather than using asymmetric systems. Let's say on server side you have SSH systems and you're using asymmetric keys, but you might also use certificates on your SSH management. And PGP is some other type of key system entirely. And on the mainframe, you could have all these different types of systems. And everywhere else, you've got a mix of lots of different types of cryptographic objects that are managed completely different ways. You don't treat an asymmetric key pair the same way as you treat a symmetric key. You don't treat a certificate the same way that you treat an asymmetric key pair or PGP keyring or nonces or passwords or salt or whatever the case may be. So this is a pretty broad problem to overcome. As a customer in this space, myself and a lot of other people started to push on the vendors, IBM, RSA, the storage vendors, and said, look, I like your products, but I'm not going to buy another one until I can actually use one system to manage the keys across multiple environments. And the reason this is so important is that encryption is a business critical service. Right? You're not encrypting stuff you don't care about. You only encrypt the stuff that's the most valuable. The reality is that when you encrypt something, you complicate your business processes. What's the besides encrypting a piece of data? What's the other most important thing that you can do? Decrypt the data, right? So it's equally important to be able to encrypt data as it is to decrypt data. Probably even more important to be able to decrypt data, right? Because you need to know who should be allowed to decrypt this data, who's allowed to use it, all these different types of use cases. But it totally impacts your business process, right? You think about the key archive situation. You write data to tape, you archive it, you encrypt this data on the tape. And then you ship it to Iron Mountain or whatever the European equivalent is of the offsite storage, right? If you don't know who can decrypt that data, when it gets back so you can restore it, you're going to have a tape with useless data. Without the keys to do the work, it's just ones and zeros that don't mean anything to you. The other thing I want to mention here is value transfer from data to keys. And this is something that not even a lot of enterprise practitioners in security understand. When you encrypt a piece of data, you transfer the business value from the data to the keys that were used to encrypt that data. So for all intents and purposes, the key is your data at that point. So it doesn't make any sense to, and it's, in some cases, I'll go back for a second, some cases when you encrypt data, you're super concentrating the value of that data into one key or a set of keys. So it doesn't do you any good to treat keys as public data, and everybody should know that. Symmetric keys have to be secret, private keys, private, right? No, it's yes. So the protections that you apply to the data in the clear, you should also apply protections to the keys themselves, right? This is without the key, data is useless. So this is a very important concept, and it's important for your business partners in your organization to understand this as well. So I did say this is a death match. This isn't so much as a death match as it is a the rock'em sock'em here, but I want you to all think about this from the outside. I've had a lot of questions because people I know know that I'm on the standards, different committees and things like that. And they come to me and they say, "Well, these standards aren't they gonna make everything great, or why are there so many standards? Why isn't there just one key management standard?" So let's go through the different pieces. The first one I want to talk about is called KeyMap. This is an OASIS committee. It stands for Key Management Interoperability Protocol. I'm a member of this committee. I'm a member of this one and one of the other OASIS committees that we'll talk about in a minute. KeyMap started very recently. It actually was started this year. The very first meeting was at RSA US this year. And since nobody is from EMC or RSA, I can kind of dish on some of this. The way that KeyMap came about is that the IEEE 1619.3 committee, which is that one there, was very focused on storage. A lot of the members of the IEEE committee weren't necessarily satisfied with the way that that committee was going, and they decided to found this KeyMap committee. And you can't tell anybody this stuff because if you do, I'll deny it, and then it just didn't happen. But the KeyMap protocol is a way for different devices, different actors in the key management lifecycle to communicate with each other, which is something that the IEEE standard had yet to define. And they were kind of in a gridlock, and there was typical standard stuff, people not liking each other, and one vendor didn't like some other vendor's approach, that sort of stuff. So KeyMap was formed with the express goal of creating a protocol for different devices to be able to communicate and pass keys, generate keys, store keys, all these sorts of things. It's kind of a logical thing to do, right? You've got a box that has some keys, and you've got another box somewhere else that has some keys. You want to be able to move keys around, or generate keys, or request keys, or do different things like that. So KeyMap was formed, and I'll read this section of the charter here because I think it's important to understand the charter that each one of these has been started with. So KeyMap will develop specifications for the interoperability of key management, KEMI, I shortened to, or key management, I shortened to KM. KM services with KM clients. Will address anticipated customer requirements for key lifecycle management, generation, refresh, distribution, tracking, lifecycle, states, archive, and destruction. Key sharing, long-term availability of crypto objects of all types. So if you're looking at this and you're going, wow, that's a lot of stuff, man. That's a lot of information that could happen there. That's a pretty broad protocol. So in scope for this is just about everything. The founders of the committee and the committee itself, and again, I'm one of the members of this committee, believe that a protocol that defines the interoperability between devices through use cases and different profiles for different systems should be pretty inclusive. The things that are out of scope are the implementation of the system. So what I mean by that is KeyMap isn't going to publish code. I think there's some sample code. There might be some sample implementation stuff, but the committee itself is not going to publish code. Nor is it going to publish a box, right? You build a box or anything like that. This is an open standard. So the actual implementation details of how you would implement this protocol are up in the air. So from just kind of an aside, from a security perspective, this could be good or bad, right? If there are mistakes or choices that the protocol makes either explicitly or implicitly, then you can either enhance or detract from those different mistakes or decisions in an implementation. So that's an important thing to think about is this standard will be published. The members of this committee include people like IBM, Thales, RSA, EMC, Cisco, SafeNet, who else I got up there? LSI, a couple others. So all the major vendors that are out there in the security space, all the major vendors that are in the storage space, because a lot of them came over from this IEEE committee. So all of these vendors are going to develop systems that will conform to this standard. So tape systems, tape libraries, HSMs, crypto libraries for clients, all that sort of stuff. So I probably should have put this one first, but sorry about that. IEEE 1619.3. So IEEE committees are numeric. Each one has a specific meaning and all that sort of stuff. I'm not going to go into that. 1619.3 is a subcommittee from the 1619 working group. The 1619 working group is the, where did I put it? Security and Storage Working Group. And members of this committee are same types of folks, right? Sun, Vormetric, Cisco, EMC, RSA, LSI, IBM. So similar types of systems, similar types of folks. Now, the goal of this committee is very different than KeyMap. And I'll read this here. The standard defines methods for the storage, management, distribution of cryptographic keys used for the protection of stored data. So you didn't see that sort of language in the KeyMap charter, and it's right here, defining the scope of this standard. The standard augments existing key management methodologies to address issues specific to cryptographic protection of stored data. Again, there it is, stored data. This includes stored data protected by compliant implementations of other standards in the IEEE 1619.3 family. So I apologize if I speak too quickly here, but 1619 family has a .1, .2, and .3 subgroups. .3 is this one, but the other two groups also have some impact in the cryptographic space. So they're not focused on the standards. So in scope here, as it says right here in the charter, and you can look this stuff up. This stuff's public. If you go do a search for this committee, you can go find lots of information. Protection of stored data. The way they define that is kind of nebulous, but the first application was tapes. The second application was disk. So obviously you store data on disk, you store data on tape. Interfaces, methods, and algorithms is the pieces of the standard that they define. So allowed algorithms include NIST-approved modes of AES. So that's an example there. An approved method might be HMACing or something like that. Out of scope here is a transport encryption and non-storage use cases. So they don't care much about SSL. They don't care much about application integration. Not too much interest in asymmetric key signing, anything like that. The best way that I can describe the standard is that it's a set of use cases that have been standardized so that one tape library or one storage library, some physical system, can interoperate with some other vendor's system. And when the crypto application or the data that's encrypted on one system can be successfully decrypted on another system through the exchange of, after lunch thing, through the exchange of the keys and different information required to decrypt the data. If anybody's got questions, please just raise the hand. I don't mind at all. So the third one we're going to talk about here is EKMI. And this is another OASIS. Everybody familiar with OASIS? It's an open standards group. This one is EKMI, which stands for Enterprise Key Management Infrastructure. So this is this started about 2007. I think I joined this committee in mid 2007. And it was started by a guy named Arshad Noor. I don't know, some of you might know Arshad. He's the CTO over at StrongKey. And what they basically did was they took their existing protocol that they used in their products and made it open source. It's evolved quite a bit beyond that today, but that's basically where this started. What's interesting about this committee from a participation perspective is that there's not a lot of vendor participation. And the vendors that are involved are definitely not the heavy hitters in the security and key management cryptographic space. You've got Red Hat. The current chair of the committee is from Red Hat. CA. Wells Fargo, which is a bank in the United States. PayPal, I think everybody knows who PayPal is, right? Prime Key, a company that's out of Europe here. Again, not a heavy player in the security or cryptographic space. But what is interesting from a participation perspective is that these are all folks that are very interested in application integration of cryptography rather than box level applications. So no representation, I won't say no, but there's very limited representation from HSM vendors. Everybody know what an HSM is? Hardware security module. It's a device you plug into your network or plug into a box, or it's a card you plug into a system. That's where you store keys and do secure operations. So I'll go through some of the bullet points on the charter, and you'll see some overlap very quickly here with some of the other stuff here. So the technical committee will create use cases that describe how and where protocols intended to create will be used. These are the different use cases. Define symmetric key management protocols, ensure cross-implementation interoperability, create a test suite, allow different implementations of this protocol to be certified, provide guidance on how symmetric key management infrastructure may be secured using asymmetric keys. Other standards organizations focus on disciplines outside of OASIS will provide input on how enterprise key management infrastructures may be managed. Other activities educate users. So again, what's in scope here is basically all symmetric keys, and beyond that, all symmetric secrets, including salts or hashes, salt hash, that sort of thing, secured using defined infrastructure. Now, beyond the message that is defined in EKMI, they also define an architecture, so to speak. So Arshad's vision, the first chair of the committee, was to define not only a language or a protocol, an agreement upon how to exchange symmetric keys, but also a way to do this securely. So the way that they decided to do this was to implement an asymmetric system, PKI basically, right? So, and this is a component that's maybe lacking in some of the other systems. The risk that you run in a symmetric key system is that you'll receive a symmetric key that exists that isn't authenticated, is not applicable, it came from an attacker, whatever the case may be. And your key management system, unless they authenticate who that user is, isn't going to know that that key is a bad key. So then some other application that requests this key from the key server would receive a key from a bad guy. So the way to get around this is to use an authentication mechanism that uses a mature trust model, PKI. But what's interesting here is that out of scope is asymmetric key management. There's no message in the protocol to exchange private keys or public keys, for example, in the same manner you would exchange symmetric keys. And again, implementation is sort of left up to the development folks. One other thing to note, and you'll see this in a little bit, this is a very XML. It's, well, not very XML, it's all XML. It's all XML all the time. The last one is IETF KeyProv. IETF, the KeyProv group, it's a little bit of a, I don't know, an enigma, I guess, because the activity in the committee has been fairly sporadic. And that's not something you want in a standards group, right? You want a standard to be well-defined. You want the participants to be active. You want them to be vocal in the community. You want them to push this stuff out there so that it gets adopted. Unfortunately, the IETF group has not been as active as it probably should be. And that's changed a little bit recently. Very recently, there's been quite a bit more activity. I think there's been some face changes and things like that. So that's a good thing. But this particular protocol is focused specifically on the provisioning of symmetric keys. So if you think about a cell phone or a USB stick or I don't know, any kind of system or device and application, whatever the case may be, that's internet attached, that does not have a symmetric key provision to it today, let's say. This protocol, this standard, attempts to define a way to provision keys on remote systems. So I'll go through this again. Define protocols and data formats necessary for provisioning symmetric cryptographic keys and associated attributes. So when they say associated attributes, they mean things like key length or use or things like that. And consider cases related to the use of shared symmetric key tokens. Other use cases may be considered for the purpose of avoiding unnecessary restrictions, design, ensure for future extensibility. So in scope, provision existing keys. This is not meant to be a language or a protocol to exchange keys back and forth between devices. And out of scope, asymmetric keys in specific implementations. So the common thread through all four of these is that there's very little consideration for asymmetric key management, very little consideration for certificate key management or even certificate management as a whole. Oh, I should probably mention this. Some of the participants on this one here include NIST, which is an American organization, Active Identity, some others. It's, again, not a who's who of cryptographic products or security products in general. What was I saying before? Oh, asymmetric. If you think about this from a customer perspective, I know this was the problem I had in my environment. Symmetric keys, much more prevalent than certificates. I might have a couple of thousand certificates, but I might have several thousand symmetric keys, especially in the financial industry. I might not track asymmetric key pairs at all. I might leave that to users, foolishly. PGP key rings probably wouldn't manage that too much at all. So symmetric keys, these are the ones that live in the boxes that protect PIN information, credit card information, bank information, social security, all of that sort of stuff. So it's a level higher than what you might normally protect with some of the other cryptographic controls. So again, from a customer perspective, I might have 11 or 12 different Talus HSMs and 15 SafeNet HSMs and I don't know, 12 Atala HSMs or something like that. And getting them all to talk together just wasn't happening. So from an interoperability perspective, that was the problem that the vendor community was trying to solve when some of these standards started up. So we'll size up the competition here. That was pretty much just an overview of this stuff. So we'll start to really get into the details here next. So let's go over KeyMap, and again, that's a key management interoperability protocol. The standard is at community draft level right now. It's at a 1.0 spec, basically. I don't know if it's been released fully for comments or not yet. I'm pretty sure it has. There's a meeting today. I think it's actually happening now, so yeah, somewhere around now. So I will be missing that. It's a binary protocol. The other messages that you'll see, these are all XML based, but this is a binary protocol. And if you think about where these vendors were coming from, binary communication means more to them than XML. They want box-to-box communication, not Java applet to web browser communication. It's a standard TTLV tag type length value. It can be nested. I'll show you an example of that so you'll see what the message looks like. The standard itself defines objects, attributes, and operations. So you can think of an object as a base object like a key block, key value, key wrapping data. This is, it's sort of, you can think of it kind of like metadata maybe. The objects, and again in the objects class, there's managed objects, and so these are the secret pieces. But it can also include public pieces like certificates, key parts, template data, things like that. The attributes, this is more appropriately metadata, but There's some of that crossover into base objects as well. The attributes can include things like the identifier, the state of the key. When you think about key states, it's the lifespan of the key. Is this an archived key? Should I destroy this key? The different life steps of a key. Usage limits, you can set dates, limitations on keys, things like that. Obviously, an algorithm is an attribute of a key. For example, if I use, if I say it's triple DES or 2T DES, then my key value in the object is going to be different than it would be if I specified AES 128 for length or whatever. Issuer, application data, pretty basic stuff. And the operations. So I've got this thing, it's a key blob. What am I going to do with it? Or maybe I need to create a new one. So these are the different operations that are defined. Register, read key, derive, and there's different derivation operations and things like that. So I can also destroy a key. The protocol has a concept for uniqueness for keys. So there's a global uniqueness for a key identifier. And this is important so that you don't have keys that are named the same thing across multiple key management systems or even across organizations. Obviously, the list isn't all inclusive here. How am I doing on time, actually? Oh. Try to go through this a little faster. 1619.3 is in draft 7. That came out in August 2009. Draft 8, I've seen some notes on the board that says that, hey, there's some modifications for draft 8. It defines a key management architecture model. If you're interested in this stuff, I strongly recommend you go and grab the standard and flip through it really quickly. It's very interesting stuff if you like key management, I guess. So you get an understanding of what it is that they're trying to define. Models, objects, boring stuff. Models also specific to data at rest. So again, the important piece here is that it does not define a message between the different actors. So one box and some other box, they've got this standard to say how they should perform an action. So it's a way to say how am I going to encrypt a particular block of data so that everybody else that conforms to the standard can then decrypt this block or understand that it's an encrypted block. But the message is not defined. But they are proposing to adopt the KeyMap binary protocol for communication. When I show it to you, people like XML. Everybody like XML over binary? XML, yeah, XML. Who likes binary? Yeah. I don't like it, but you'll see it. It's just a bunch of numbers. It reminds me of like some really ugly financial protocols. 1619.3 also defines a desire or request for an XML specific protocol. So even if they do adopt a KeyMap standard, they'll probably adopt one of the other pieces of data out there. KeyMap has also said, well, maybe we'll have an XML standard. IEEE has said, well, we've got this piece in the standard that maybe we can adopt the EKMI piece. That's kind of up in the air. We'll see. EKMI that's not the name of the actual protocol, oddly enough, or not oddly enough. There's two different protocols for EKMI, and that's Enterprise Key Management Infrastructure. Follow along. SKSML, which is Symmetric Key Services Markup Language, and mobile symmetric key services markup language. And I didn't put that on here, but there's a subcommittee off of EKMI that's specifically focused on a key management between mobile devices. The protocol not only defines the semantics, the XML language, but also the components required. So these are the components: the symmetric key management system, which is kind of the whole thing. Symmetric key server, symmetric key client library. That's what all these little acronyms are. And it uses PKI as a trust mechanism for exchange. It's not defined how the PKI is used. You could use PK little I. I don't know if that's a concept that's familiar with folks, rather than PK big I. And some of you might have the scars, the PKI scars on your back. It's kind of totally aside. It's kind of funny that in the financial space, a lot of people are moving towards PKI systems because they think that it reduces the key management overhead, which is a bunch of crap. But it doesn't matter because somebody sold them a bill of goods. So you think that they would learn from the 90s, right? With the PKI rollouts, they were just a total nightmare. But people don't learn, whatever. EKMI has a very well-defined set of requests and responses. I'll show you an example of a request. Very long stuff, doesn't fit on a PowerPoint very well. I tried to fit it on as best as I could, so we'll walk through those in a few minutes. IETF key prov. One thing that they mentioned is they leverage RFC 4758, which is CT-KIP, cryptographic token key initialization protocol. If you want to read that RFC, go to rfc.net. You can have fun, but we're not doing that today. IETF defines 3 documents. DSKPP, which is Dynamic Symmetric Key Provisioning Protocol, I think. And PSKC, which I forgot now too. I have to go back here and look. I always forget this one. Oh well. No, there it is. Portable symmetric key container. There we go. Okay. And there are different stages of documentation. Oh, the symmetric key format docs. So this is a definition of how the key blobs are supposed to be formed. Draft 9, Draft 4, Draft 6. If you know IETF, then you know that the different versions are always .1 or 1.0 until certain levels. So these are different draft versions. It does, so differently than some of the other pieces, it does not define an architecture per se, but it does define pretty clearly the use cases around provisioning keys to these internet accessible cryptographic systems. So you might think of I think cell phone or even a client library on a remote system. Those are probably the things that are most applicable here. So you got a cell phone, it's got some sort of secret in it. When it was injected at a factory or whatever, you know what that secret is. You can send some other secret material to the device. I'll go through the protocol in a second here, but you can see how this might be useful to be able to provision new keys to a system that maybe didn't have the keys before. Typical client-server interaction, there's a 2-pass and a 4-pass protocol. It's very, if you look at it on a diagram, you would see it right away. 2-pass, you send a server hello and authentication credentials and what you want to do, and then you get a response back. Pretty basic. 4-pass is similar, but it breaks down the middle pieces into two other pieces. So what do the messages look like? Like I said, it's all ones and zeros. This is the message layout for KeyMap. The top piece up here, you can see the unique identifier for this particular operation. And as I mentioned earlier, this is sort of a nested binary protocol. So tag type, length value, each one that's on the inside is more specific than the one it is wrapped with. So that top big string of numbers is the message. And that big string of numbers, I wish I had my pointer, it broke, sorry. That big string of numbers is laid out in these different pieces here. So If you look at that big string of numbers, and I don't know if it's legible all the way in the back, but if you look at the first string of numbers there, 42078, that means that it is a request message. And it breaks it down all the way down to the very end, which is, here's the integer type. So that's what the message looks like. So again, thinking back to what the purpose of this particular committee, or what the goal of this committee was, so they wanted to be able to move data back and forth between boxes. So this is much more efficient than passing XML around. I'm gonna skip that right there, and which would look something like that. You know, a lot of information. If I do it in a number string, shorter, I could parse it, whatever the case may be. Plus, these guys are like gearheads, and they thought this was better. And application guys, they can just smoke that XML crack. So, 1619.3, I'm not going to show you a message because no messages are defined. But they do very rigidly define some things called object names. So if you think about down here, if you look at these here, KM, key object, and this would be the location, a URI for a particular object. And you can define all the objects that are defined in the standard through a URI. Oops. And you can see right here, here's a policy URI. Here's a key URI. So lots of different ways to address different pieces of information. I truncated this XSD. This is the EKMI symmetric key XSD request. You can, this is all, again, public information. You can go look at it. It's not terribly mind-blowing. But you can look at this here, and you can see real basic. Skip that documentation stuff. That's just worthless comments. You look at this first element here, which is global key. Similar to the other standards, there's an idea of global uniqueness for keys. And the way that they approach global uniqueness is different depending on which standard it is. Some go to IANA. One of them, I think EKMI went to the guys that assign MAC numbers. Since we're running short here, I'm just going to flip through these. This is the 2-pass key request sample for IETF. Again, basic stuff. It doesn't take much to get a key from one place to another. I do want to talk just for a second about overlap here. When we started, we say, well, which one's going to come out on top? Who's going to win? Who's going to lose? The reality is that there's a lot of overlap in the different places, and there's a lot of places that IETF, for example, does not touch at all key storage, whereas KeyMap is very focused on interoperability between storage devices. IEEE is totally storage focused, stored data at rest. So you can look at the more application-friendly stuff, KeyProv, EKMI, a new future KeyMap piece. And I think I'm probably 1 second off of time. The reality is there's no easy answers. I believe that the EKMI standard is probably going to go by the wayside. I think the IETF standard will get some adoption, but it'll be in very tight use cases. And the clear winners are going to be KeyMap as a Uber standard, and IEEE in the storage space. So, any questions? Yes?
Now that next year the root DNS will be signed with DNSSEC, and probably some TLDs and enterprise will also move to DNSSEC. Any recommendations on how to handle keys for that?
That's sort of a tough question because for DNSSEC, it's a pretty big, lot of implications there. A couple years ago, the Department of Homeland Security tried to get VeriSign to give up the DNSSEC route. As far as I know, they told them to shove it. So VeriSign is it's VeriSign's problem at this point, but that's like a handful of keys, not hundreds of thousands of keys. I think it's a little easier to manage.
On the enterprises, all the other lanes?
I'm not real sure how that's going to play out. I don't think that any of these standards are going to touch that stuff.
I think we have to stop here because the next speaker also wants to speak. So maybe we can take additional questions outside. I saw you had some questions. Maybe you can get together. Thank you.